Good afternoon, everyone. I'm Titus Winters. I'm going to talk today about the new standing document that is detailing the standard library compatibility guidelines. But first, we will start with a question. When you upgrade, assuming you ever have, to a new version of the language, is that an easy process? Show of hands. How many of you are like, yeah, I could do that in a day? Yeah, couple of you. Some of you are lying. That's cute. Right? But most of you, no. This is not like a straightforward process. Would you like it to be easier? Yeah, much better. Hands go up. And speaking of hands going up, I would love this to be a fairly interactive talk. So if there's, things on your mind or I'm saying things that are just nonsense, please disagree, that'd be great. There's a hand.
When you say upgrade, do you mean just sort of flipping the language switch or adopting?
When we say upgrade, do we mean just flipping the language switch or do we mean adopting? In this case, I actually just mean flipping the language switch, which is, in my experience, hard enough. Actually, adopting is a whole additional, longer term, deeper thing. How's about, if you want it to be easier, would you like me to tell you the types of changes that the committee might make and therefore make your upgrade process harder? If so, you're in the right room. If, on the other hand, your code is totally stable, right? Your project works and you will never upgrade to the new version of the language, right? And note when I say never here, that is stronger than not this year or not planning on it, right? If you visualize yourself and your project in 2030 and think about what version of C++ you're using at that point, what version of the C++ language your project is using in 2030, did the imaginary you do some work to flip that switch? Or is it still on today's version, right? 03 or 11 or 14 or 17, right? If you are never going to upgrade, and you are pretty sure of that, you're in the wrong room, and you should be seeing Ben's talk. It is an excellent talk. You can leave now. No? No? Catch it on YouTube. I definitely recommend it, right? Since we all agree that we are probably going to upgrade our code base to using a newer version of the language at some point, let's talk about how to try to make that easier. First, we need to know why this is hard. Okay? So here's a quiz. Which of the following three snippets of annoying code is defined to be UB? Could be none of them, could be all of them. The question was, am I talking C++ 11? I think that it actually doesn't matter. I think that the rule is the same. So, how many of you think that the first one is UB? How many of you think the second one is UB? How many of you think the third one is UB? A lot of hands went up for all of those. And I believe that if you peer into the tea leaves, I think the first one actually doesn't compile, but even if it did, it wouldn't be UB. 2 and 3 are actually defined by the standard to be UB. And even still, these aren't UB. These aren't undefined behavior in the sense that the compiler is going to spot that you did that and be like, haha, you did that, and I know that there's no UB in a valid program, and therefore I know that this branch of your code or this TU is never reached, and I can just evaporate it all in a puff of optimization, right? This is not that kind of UB, right? I mean, technically it is defined to be UB in the standard, so if Chandler decided that he had some crazy optimization that he could implement in Clang based on you doing one of these things, technically that's conforming, but that would be cray-cray. These are UB really at most in the sense that the library might not function properly. And in all reasonable likelihood, if you went back far enough, I believe that they are marked UB in order for the committee to try to carve out room to make changes in these areas in future standards, right? Given all of the hype about UB lately, that seems like maybe not the right way to say, hey, if you want to upgrade in the future, don't do this, right? Labeling these things as the scary, scary demon that everyone is afraid of is probably not the right way to just say, hey, please don't do this if you want your upgrade to be easy, right? Because practically speaking, my belief is that if you aren't actually going to upgrade or change standard libraries or change compilers, like we honestly don't super care if you're going to do that, right? You do you, right? Again, that is only in the case that you know that you're not going to upgrade, right? So, and honestly, that first bullet point is still terribly iffy, right? If someone came up with a compelling reason to add an overload to free functions in the standard library, move is actually not a great example, but or to change the function signature and add a default argument, right? If a committee member wrote a paper along those lines and like had a good reason to do it, we would be like, yeah, sure, let's do that. That sounds good, right? I'm 90% sure that we could be convinced to do that, but this code would still break, right? Because you're supposed to call the free functions in the standard library. You're supposed to call std_move. You're not supposed to treat it like it's an object. You're not supposed to observe all of the things other than, oh, I can call it, right? And worse, there has actually been some back and forth on the committee as to whether or not this is UB. Like, I think the consensus after squinting at the tea leaves and like reading through the spec very carefully is that we meant for it to be, but forgot. It's kind of not entirely clear, but anyway. All of that is to say, the committee could do a much better job on being clear about how to tell you how to upgrade cheaply. Like, what things you need to do to use the standard library responsibly so that your upgrades will be easy. But recently there is some hope, right? Last year, some of you may remember, at CppCon, I announced Abseil, Google's open source libraries, and I'm not going to say that you should go use that, but one of the concepts in all of that, one of the notions in all of that, can't say concepts anymore, one of the ideas in there that is unusual is to describe the compatibility guidelines for that library. If you obey those rules, then upgrading from version to version of that library should be free. And that led me to the obvious question, why is the C++ standard so arcane about telling you what rights the standard library reserves for itself? I clicked the wrong thing, there we go. So I started writing P0921, and that got voted in over the summer as a new standing document. This is SD-8, Standing Document 8, during the Rappersville meeting last summer. So now there is a document specifically intended for public consumption, not written in standardese, that lists what the committee reserves the right to do when making changes to the standard library. Interestingly, and if you saw this, you saw my tweet on this recently, I was told explicitly not to include examples of what types of code will break under SD-8 because too many silly things that you might be doing will break. So I revised the paper, and we dropped the examples, and SD-8 got committed and adopted, and now I'm giving you this talk. So here it is with the very clickbaity premise of everything that you might be doing in your code that the committee might break in future versions of the standard that we're not going to tell you about. Right? We aren't, of course, trying to break your code, but there are things that we have to reserve the right to do in order for the standard library to make any progress whatsoever. And if you abuse the standard library, your upgrades will go poorly. I will try to be clear about which of these changes is reasonably likely, but I will also include examples of things that are just straight up forbidden. Like, even if the committee doesn't take advantage of those rights for itself, if you and someone else both tread on forbidden ground, you will be in a bad place. So we'll dive in. What does SD-8 say? This is basically the text of SD-8. And I expect that this will get edited and expanded and refined over time. This is sort of a starting point. But I would rather us start with something so that we can actually tell you something than the old state of like, nobody could possibly know what we're asking of them. Right? So primarily, the standard reserves the right to add new names to std, add new member functions to types in std, add new overloads to existing functions, add default arguments to functions and templates, change return types, which is mostly change void to return things. Well, we've done that a couple times. And this bottom bullet, make changes to existing interfaces in a backwards compatible fashion so long as you're using those things in the way that we expected you to use them, right? This used to be a function, right? We could change it to something else that is callable, and as long as you're just calling it, it'll be fine, right? That's the type of thing that we're talking about there. To be clear, very little, maybe none of this is actually new, right? It's new in the sense that we're writing it down, but it's not new in the sense of change in committee behavior, right? This is basically enshrining existing voting patterns and behavior on the committee, right? There are things that nobody really considers when we're talking about a possible change. Like metaprogramming consistency between language versions is always off the table. Once in a while, someone on the committee says, but what about if users have done X? And then it's usually shot down by me saying, if users have done X and we start caring about that, we will never be able to make another change to the standard library. So we don't care, because I'm kind of that guy. So let me just say again, this isn't a change. This is a snapshot summary of how I think the committee has been voting. I'm just sharing all of those details with you. So we'll start here. We reserve the right to add new names to stud, right? On the surface, this is obvious, right? Without this, the standard library completely freezes. Obviously, we need the right to add things to stud. But what does this mean for you? You can't add things to stud, right? You cannot add new names to stud. Our names might collide with whatever crazy thing you did, right? If you have opened stud to say, well, they added optional in 17 and we're not using 17 yet, so I'm just gonna do this in stud, right? That's gonna go poorly for you at some point, right? When you start turning on 17, or you get a standard library that's maybe has allowed optional to leak into a 14 release, right? Your build is gonna break, right? It's either a redefinition or redefinition as a different type of symbol, but it's a build break, right? This is the obvious case. Of course, there are many other ways for us to break your build just by us adding things to namespace stud. If you have a type and also a using directive for stud, that is a using namespace stud, in the same namespace as that type, that can become a build break. This serves as your first periodic reminder. You really shouldn't ever, ever, ever using namespace in code that you care about. Using namespace, totally fine for slides, totally fine for assignments, totally garbage for code that you actually want to maintain over time. If you care enough to even maybe update things in the future, you're much better off using stud vector or instead of using namespace stud. There's a question in the back. How does this relate to specialization of hash and traits? The rules on specialization, like there are types that you are allowed to specialize, like hash. And you note that I have described everything here as adding new names, right? The name stud hash already exists. You are allowed to specialize stud hash for your type. We will get into an example of you specializing stud hash for our type, and that will be bad for you too, right? And not specifically with stud hash. I will talk about that in terms of O streams. But yeah, like the rule here is you cannot add new names to stud, okay? For specializations, you should tread carefully, but so long as you're specializing for your own type, presumably in the header that defines that type, then you should be fine. Does that answer the question? Anything else? Okay. I totally recognize that we on the committee and presenters and speakers here don't quite walk the walk on this particular point of don't using namespace stud, because a lot of the slide code that you see around here sort of infers and implies std : on things. That's so that it fits on the slides and looks pretty. Slide code doesn't have to be upgraded over time, right? Your code has a different set of requirements than slide code, okay? Honestly, there's an essay that I've been meaning to write for a few years that just has the title Context Matters, and points out that slide code is different than what you should submit in an assignment, and that is still different than writing anything that will last for decades. Kate has sort of made the same points in the keynote on Wednesday. And of course, there's all sorts of ways to make this go poorly if you're playing with using namespace, right? Like, there's a long game you can play here of how many exciting ways can I break your build as soon as you have a using namespace stood somewhere? Because remember, using namespace, a using directive, not the same as a using declaration, but a using directive, if you say using namespace, probably isn't doing what you think it is. This isn't take everything in stood and using declare it here. This isn't even when you don't find anything by lookup in this namespace, feel free to search over there as well. It's actually much messier than that. This is add everything from stood to the nearest ancestor namespace for the duration of this code block, right? So this code does not build, right? And that's not intuitive for most people. And if you find this surprising at all, you need to remember that you are probably not qualified to using namespace correctly, because it is deeply surprising, okay? If it's obvious why this is a build break, then I guess maybe you're fine, but this is a surprise for most people, okay? So anyway, that's another way that we can break you just by adding things to stood, of course, but there are more. So time for a quiz. Does anyone see how this code is dangerous? Especially the isPolite function. I will give you all a couple minutes. We have one tentative hand. Got a couple in the back. A couple people are maybe starting to see it. All right. How many letters are in the thing that kills this? 3. There's always 3 letters in the scary things. This one in particular is the scary 3-letter acronym ADL, Argument Dependent Lookup, my nemesis. If we provide a standard version of contains with a similar signature, your code will break. Hopefully break. It is also possible with some definitions of your versions of contains that with some type conversion trickery, it could be the case that our new version is a better match than your old version, and you get ours unambiguously, which could be great, or could be the devil, right? Because for something like contains, you could easily imagine those parameters being needle and haystack, or full string and target string, in which case you'll get a semantic difference at runtime, right? That's not a happy thought at all, right? So argument-dependent lookup is the devil. Side note, let's explain that. ADL, the devil, when calling an unqualified function, you form an overload set from all enclosing scopes, right? Your project, whatever namespace your project lives in, the global scope, and also all of the namespaces that are associated with any of the arguments to that function call, right? So when we are passing a string view, that means that we are nominating look in stood for this function call because we are calling that unqualified with no namespace present, right? That is wild. That is buck wild, right? This is actually how operators work, right? That's why we added it. But it triggers all the time. Secretly, under the hood, if you are ever making unqualified function calls, ADL is lurking. It's really bad. It's super scary. When I say that the rules are intricate here, the CPP reference summary page, which is so much easier than the standard, the CPP reference summary page on this is 1,500 words. It's like a college entrance essay, right? So, fun times. So we'll look at the risky code again. How can we protect ourselves from this becoming a build break? Or, a runtime behavior change, dear Lord. My best formulation of that rule is, you shouldn't make unqualified snake case function calls involving standard types. And now you start to see why the committee was maybe nervous about listing off all of the silly things that your code could be doing that you shouldn't do that will break when we upgrade the standard library, right? Because at this point in the talk, we are one bullet in on this list. And we have derived rules. Thou shalt not add new names to namespace stood. Thou shalt not add a using namespace stood. And thou shalt not make unqualified snake case calls to any function that accepts a type from stood. And I'm 90% sure that is not a complete list, right? If we played this game hard, I'm sure that we could come up with additional fun ways for your code to break by virtue of us just adding a new symbol to stood. That said, all is not lost. Most of those ways have a similar feeling, which is don't take shortcuts with stood. Don't add to it, don't play with using directives. Maybe also stay away from the global namespace because that's a hoot on its own. I really wish the ADL one wasn't an issue, but ADL is a big flame point in the committee right now. So, Jeff.
So on point C, you say don't make unqualified snake case calls. Does the committee actually promise not to introduce functions instead with some other naming convention, or is that just an empirical reality that so far they haven't?
That is an empirical reality that so far has happened, although I realized when I was watching the concepts keynote that we are spelling concepts in uppercase, so I'm not actually sure if the lookup is going to suffice. So maybe this is just don't make any unqualified calls, but that seemed even harsher. So, don't know, it's not good. Oh, any other questions? Please, please. Anyone? Yeah. Go to the mic's right there.
So would the implicit advice then be you're better off making your function naming convention specification not match stood to try to not fall into this trap accidentally?
I would honestly suggest that you just don't make unqualified function calls more so, because those are wild. Or you could go find any committee member that spends their time in language evolution and yell at them because, why you don't fix it for me, right? A little inside baseball, right? There's a message that I sent to the evolution mailing list earlier over the summer where I specifically pointed out the librarians for the standard library, Abseil, Boost, and Folly have all made credible threats that we are going to stop writing functions because ADL is too bad, right? And we cannot maintain libraries professionally and responsibly because ADL is out of control. And we were told, can you prove that there's a problem? So I cried a little, and I'm giving a very bitter talk. So.
If ADL was created for operator overloading, why doesn't it apply only to operators?
It was invented for operator overloading, but the original sort of design concept was, and I've heard this quoted at me recently still, every function and type in the same namespace is morally related, which is not how we design libraries. But that is the rule by which the language behaves. So until we can convince the language people that the librarians are really, really sad, and that there is a credible way to roll back some of ADL, we're in trouble, right? And it is unfortunately the case that that also gets into the question of there's an awful lot of code that is accidentally depending on ADL. And we could easily fix that because the compiler obviously knows what function is being invoked in a non-generic context. So we could just ship a tool that's like, okay, now we add a stood : there. Bing, we knew that you were calling stood sort. That should be fine. But it would require actually textually updating old code, and a lot of people on the committee are afraid of that. Whether they should be more afraid of that or librarians recommending that you don't write functions anymore is an open question. Okay? Yeah.
I just want to make sure I understand this correctly. You're saying I should qualify all the calls to functions in my namespace in case they're using any of the stood variable stood types?
In case they are using a type from any other namespace, in all honesty.
Just horrible.
It is horrible, yeah. Right? But if you want to be protected against this, in Hiram's talk this morning about large-scale code migrations and all of that, ADL is probably the number 2. I'm looking at all the librarians in the back. 1 problem that comes up in doing a transformation to a code base, is bad.
So I frequently do use using namespace. With
Many do.
Even. Standard chrono is a painful thing to type over and over again if I want to start referring to durations or things to the effect of that. Would you suggest as an alternative then to either just namespace alias and then always just prefix with a really, 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 really short alias for a namespace then?
Yes. I would be much more comfortable with you adding a namespace alias for those things, hopefully not in a header, but yes. I specifically tried to submit papers and push them through the committee to be like, can we stop adding deeply nested namespaces? They're not actually helping, because everyone then just declares everything, or using namespaces, and it collapses back down into the global namespace, right? When you read time point, you're not reading chrono time point. The chrono isn't helping you read that type. Right. The nested namespaces are doing us very little favor, right? There's also been a paper we're considering, maybe we actually said yes, but we're considering having a canonical alias for std.fs equals std file system, because file system's awfully long. We're starting to think about namespace hygiene a little bit more aggressively. But yeah, otherwise, yeah, there's just not a lot of great ideas. Sorry, it's a mess.
Thank you.
2 more?
Right. So would it be correct to say that any unqualified call is equivalent to calling a customization point?
Currently, yes.
That's fun. And I was also going to ask, is there any credible plan for backing out ADL?
I could do it in our code base, but we have power, and the committee is. I was just heckled. The committee is very hesitant to ask that anyone else apply a tool. So I don't know.
I guess we're kind of made the same point, but I think C is overly constrained, because if I have a function that takes a bool, I could be passing in a standard type, expecting it to be implicitly converted to bool, and ADL would still pull in the standard. So basically, you can't constrain it that way.
It's even worse than I said, yes. See? All right, so we'll move on to the next major bullet point in SD-8. We can add new methods to standard types. This is actually a little easier, so it's not a problem that we're halfway through this talk and only 2 bullets in. Basically, be careful when applying the detection idiom to standard types, right? If you are depending on, does this method, does this member exist in this type, other than just in the obvious way of calling it or referring to it, but if you're metaprogramming against it, that's fragile and not guaranteed. Generally speaking, don't metaprogram against std, right? There's a lot of metaprogramming dependence that you could add on the standard library, and that is never guaranteed. Never, ever, ever, right? Just because you happened to get something to build using template metaprogramming or HANA or whatever against the current set of containers, we do not in any way, shape, or form promise that that will continue to work in the future. When ranges lands, hopefully in 20, there's going to be some member type def changes in things and some iterator tag things and all of that. So if you're relying for some reason on the absence of those members in standard types, you're going to have a bad time. But other than metaprogramming trickery, I haven't yet been able to come up with good examples of how to break you just by us adding methods, or actually it's not methods, I think it should be names. Adding new names inside of standard types should be safe other than metaprogramming, but we'll see, I guess. John?
So as an example, for the question I'm about to ask, absel span metaprograms against a type having a .size and .data that does certain things, which are interface things you can metaprogram against. Is that okay?
It is much more okay to depend on that for the presence than the absence. And in cases like span, because std span is currently written to do the same thing, because there isn't a clear...
But that's in std, so it's allowed to.
One, it's allowed to because of that. And two, we're not 100% sure that that is a good idea. Like, it is a little bit clever that we are just saying everything that has a dot data and a size is contiguous, but there wasn't a different way to express that. So you could probably get away with it, but don't build types or functions that will change behavior when one of those things changes, right? If you had span-ish that did one thing when there was data and size and changed behavior entirely when there isn't, right? Then that prevents any type from ever suddenly becoming contiguous, because there'd be knock-on crazy changes. Is that, see the distinction there? Yeah.
More or less, thanks.
Yeah, cool. Other questions? Cool. We reserve the right to add new overloads. This means that you should not be taking the address of functions or member functions of anything in std. We generally are not promising there is a function of this signature. We are promising you can call a function of this signature. This also extends to things like std functions deduction guide, unfortunately. That was straight up a mistake, because it turns out that anywhere that std function is able to deduce which constructor and template parameters to use when just given a function pointer, it is clearly relying on the exact signature of that function pointer. So if we added a new overload to std is w alpha, this code will break. There are similar things in the proposal pipeline, even things that I sort of mostly want. Simon Brand might be in here, has an otherwise lovely proposal to add a bunch of new features to optional that require us to deal in function pointers much more regularly. And that is pretty troubling, because this code will break if size picks up an overload or changes in any other way. I fundamentally cannot be okay with this until at least the point where the language understands that, as I was saying on Monday, the way that people think about design is in terms of overload sets, not basic function pointers, especially in cases like this where the function pointers only make sense for a particular signature. Jeff.
So there have been proposals floating around from time to time to have a concise syntax for capturing an entire overload set as a functor. Would that help with this?
I deeply think so. Like, I think there really, really needs to be a solution to that. I specifically sent a wish list to EWG earlier in the year asking for that, among other things. So we'll see. It's hard. I understand that it's hard, yes. But we're your big user. Figure it out. If you squint, this we reserve the right to add overloads sort of extends to things like who has the right to define operator ostream for vector of string or std hash. And here we get into sort of icky new territory, because there's two ways that this could go wrong. Any guesses how this goes wrong? If one's a better match or it's ambiguous, right, then the obvious one is if the committee does this, then the new ostream overload is declared in iostream and your build breaks because it's a redefinition or similar. And it's reasonably likely that your tests and runtime break even after you stop defining your own, because we very well might not put out exactly the same output format. Right, so you're going to get some like behavioral change as well. But there is also a more nefarious possibility. When you do this, when you add ostream for vector string, sneakily, knowing that it is a right reserved for the committee because we own string, we own vector, you are not specializing for any type that you have any right to, right? You may also link with someone else who has taken the same sneaky step. And then what do you get? ODR violations. Even if the library that you are linking to doesn't export this trickery in a header and everything builds, you are still in ODR land. Which brings us to, I should probably do a quick refresher on ODR. ODR is the one definition rule. Everything that is used has to be defined at least once. Most things, most of the obvious things, must be defined exactly once, right? You must have exactly one definition of a function and a variable. Other things, like classes and templates and inline functions, may be defined more than once to allow for them to exist in headers and those headers to be compiled from multiple TUs. So long as they are identical in each definition, that is, you're not playing any games with how that header is treated. There's no macros. There's no actual different copy of it. And they have to mean the same thing every time that they're evaluated, right? You can't have some overload set that's visible in one case that causes the template to go one way and not visible in a different compilation that causes the template to go a different way, right? And if you make it really easy and obvious for the compiler that there are two things of the same name when there should only be one thing, there is no problem, right? If you type int x, semicolon, int x, semicolon, into Godbolt, you get a build break, duh, right? And like I said, we're only talking definitions, not declarations. So like if you just declare it, you can declare it multiple times, that's fine. You just can only define it one time. But keep in mind C++'s heritage of separate compilation and linkage, right? If we build foo.cc and bar.cc separately, and they both are including foo.h, then how is this code ever gonna work, right? We have a const int that was declared in two places and used, and that's defined differently. Best case, whichever one gets linked first, right? You could very well say, even if it's built separately, we could add a step to the linker to try to identify redefinitions, to which I answer, when my optimizer does even basic constant folding, it stops being obvious that these symbols even exist. But the behavior that is relying on them under as if, right? Who knows what is gonna happen here, right? It is ODR, it is undefined behavior, right? We are off to the races on your program becoming inscrutable. And these are just the super basic things, right? This is an int, right? Where the rule is easy and must be only one. When we get into templates and inline functions, right? Checking that those are the same in every TU where they were defined starts looking an awful lot like reparsing or recompiling everything. All of which is to say that ODR is the way that the committee says, please don't do weird things, right? We're going to assume that when we see you talking about a foo, that it's the same foo that you've been talking about everywhere else in the program, right? A foo in one TU is the same as a foo in another TU. And we're gonna optimize along those lines. You get faster compilation time if you don't make us check your work that you haven't done anything weird, right? And that sort of brings us back to what happens when you define operators for the standard library, and some other library that you depend upon does as well. Now we have one function with two implementations. If there are declarations for these in headers, they might be compatible, or they might not be in the good case, and then you just have a build break. But it's probably the case that this violation of ODR just means that any vector of int in this program gets printed in one fashion or the other. I think the difference here is commas between elements. But it could get arbitrarily weird, right? The inliner is going to know some things. The optimizer is going to assume some things, right? If you start taking the address of these operators, for instance, or anything gets inlined or passed to a std function, you can imagine the optimizer getting involved in interesting ways, and then all bets are super off, right? The as-if rule and UB play interesting games. If the optimizer is allowed to do anything it likes that isn't observable in a well-defined program, programs with UB are not well-defined. Programs with ODR are UB. Even small differences, like how many instructions are in the inline representation here, could throw off the behavior of your program in arbitrarily complicated ways. Right? You will not be able to debug this if this goes bad. In practice, some ODR violations are basically benign, and when they are not benign, they are unfathomably difficult to debug. You will not be able to reason about anything. it will be a nightmare. All of which also goes back to, we have the right to add these overloads. You do not. Even if we don't take advantage of that, and you know that we're not going to take advantage of that, you probably shouldn't either, right? If you can be absolutely 100% sure that nobody in your code base or any of your dependencies, anything that gets linked in, is going to define these overloads, you can probably get away with it. But if that certainty turns out to be unjustified, and there is a redefinition somewhere, you can end up with an arbitrarily bad time. So yeah, don't add overloads that the committee might, even if you're pretty sure that we won't. It is not worth it. If you want a standard way to print a vector of ints, do it yourself in your own namespace. It's safer.
Yeah, I was going to ask something about like that. If I have a printer or a printer class that has, stream, if that's safe.
Yeah, like so long as you are dealing in types of your own, totally fine, right? All of this problem boils down to specifically adding that symbol, right? And it is way too easy. Like, how many people have spotted someone overloading vector string in their code base? I definitely have, right? Because it'll work for a while until it stops working. And when it stops working, you have no chance. That's adding overloads. Please don't take the address of functions or member functions. Don't define or specialize anything for types that you don't own, right? Do not play with IO streams for types that you do not own. Do not define swap for types you don't own. I don't know why you would, right? If you don't have the ability to edit the .h file for a type, not yours. Don't do it, okay? We reserve the right to add default arguments. This is very similar to previous things. Function pointers to things in std are bad. And also, don't forward declare things from std. That is none of your business. Because, like, yes, you can get this forward declaration at the top of the screen to build, right? You can get this whole screen section to build without including vector, right? But if or when we decide that vector needs a third template parameter, which we would default so that existing code would still work, your forward declaration doesn't match our definition of vector, and your build breaks, right? You are not allowed to forward declare things out of std, right? This, if you squint at it, this is, you could view it as adding names to std, because if you went out of your way to avoid including vector, then for this translation unit, it's a new name, right? Not your business. No forward declarations. We will sometimes change return types. This will always happen in a compatible fashion. The best example I can think of is changing std vector in placeback from returning void to returning a reference to the new object. It's usually going to be pretty benign things, but still don't metaprogram against our things to say like, oh, this has to be returning void. Practically speaking, I think that the guidance is just metaprogramming, and also this one, which is kind of weird. Just because you know that our function returns void doesn't mean that in a void function you can return it, right? Because that would be a build break if we decided to change this to returning a thing, right? Also, it's just kind of weird. Don't do that. Don't be weird. And then there's, we reserve the right to make changes to existing interfaces in a fashion that is backwards compatible. This is basically a lot of words to say, if it's a function, call it. If it's a type, instantiate it, and don't do weird things, right? The more weird things you do, the harder it is for us to make any changes to anything. And you want the standard library to evolve. We'll give you good things. Don't make it hard for us. There are some things that I think will change and get extended in SD-8. There's been discussion, which I think was mostly just a copy-paste error on my part, for types that have both a copy and a move. Don't rely on how many specific copies and moves happen, right? Like, if the correctness of your program depends on there being one copy and one move, as opposed to two moves, I don't care, right? Like, we're gonna optimize things for you. Don't make it harder for us, right? We will try to make your code more efficient, but you cannot have semantic requirements on these sorts of things. And Greg has a...
Yeah, I wanted to go back because I thought you were going to mention something you didn't. You said that you were allowed to widen the return types of functions.
I think I might be wrong on that.
I was going to say, it would mean that you could never pass any of those values to printf, which is surprising to me.
Yeah, I think aspirationally, I would like us to be able to make compatible changes, and that example is false. Like, the void to some other things works, and I will have to cut that for the next update of SD-8.
All right, thanks.
Yes, well spotted. My team will not let me get away with things. Yeah, don't complain to us when we make things cheaper. And then there is an elephant in the room. And in this case, that elephant is the thing I refer to in most talks, and that has already been referenced in a talk today, which is Hirams Law. With a sufficient number of users of an API, it does not matter what you promise, all observable behaviors of your system will be depended upon by someone, right? This is Googler shorthand, but becoming more known in the rest of the world. You could cite it at hiramslaw.com if you want it. In short, this is the thermodynamic truth of software engineering, right? Over time, this is the entropy that we fight against when we are trying to make changes. And you can say that all of SD-8 just flies in the face of Hirams Law. But in short, I disagree, right? There's a difference between recognizing that entropy is a thing and just burning everything, right? Like, I know that your upgrades are never going to be perfect because I know that you're not going to have perfect adherence to this in a big project. Like, Lord knows we don't, right? We try really, really hard to train all of our users, all of our programmers, like, please don't abuse our libraries like this. And then we make changes and we yell and scream and rant about the fact that they did silly things, right? But they do fewer of them when we try to train them not to, right? SD-8 is my approach, my attempt to tell you, let me help you. I know it will not be perfect, right? But it is better than nothing, right? We want your upgrade to be easy. It is a lot easier for us on the committee if we only have to consider your use of a language version a couple years old rather than all 20 years of legacy baggage. And that's just what we're looking for, efficiency for you and for us. That efficiency in this context comes just in the form of increased communication, clarity, and eventually tooling surrounding the proper usage of a library. We will have better tooling, right? There will be, I am positive, static analysis warnings in things like CppCon that when you say, yes, I would like to know what things I am doing that will make it hard for me to upgrade in the future, right? It is perfectly reasonable for CppCon to spot most or all of these things. And other static analysis and linting tools can and should be doing that. And we'll try to work with them to, here's SD-8. Tool it, right? Let's help everyone. And you should be able to, similarly, like I said at the beginning of the talk, you should be able to silence all of these warnings if you know legitimately that your code is never going to update, or you just don't care about how hard it is when you do update, right? These are not UB. These are, please don't do this. You're just going to hurt yourself when you try to do an upgrade, right? We've started releasing this type of thing for Abseil. There are CppCon checks against, please do not open our internal namespaces, which you would hope didn't require tooling, but apparently it does. And I suspect that, I am positive that we'll do the same thing for SD-8. And now, this is the part of the program where I try to predict the future and get into the big picture a little bit, right? I see signs already that we're moving to a world where there is a clearer give and take between API providers and API consumers, because there has to be, right? Without that, without the fact that, this is a two-way street, change becomes impossible. And all of the momentum that the standard has built up over the past few years will come to grinding to a screeching halt. Consider something like HANA. It is not hard to imagine using HANA in a fairly obvious way to build metaprogramming reliance, or reflection for that matter, on every surface feature in the standard library. And the static reflection features seem on track for C++ 23. Right? If your code stops working when the count of types in namespace stood changes, we're in trouble, right? Obviously. So clearly, API providers have to be clearer about what types of usage they expect and what types of changes they're going to make, right? We, as a committee, haven't been particularly clear on that in the past, and it's led to a lot of confusion, and a lot of abusive constraints just crept in via Hirams Law. So there has to be clarity about the difference between, I got this to work, and this is actually okay and supported and will continue to be okay going forward. This is particularly pressing in C++, right? Because of things like ODR, where we would love to prevent you from doing that, but it is too costly for us to actually check for it, right? This is a language that is so deeply concerned with performance. There are lots of things that in other languages, the languages that are pleasant and comfortable, those things would be checked and prevented. Like, you could not do those things in a language like Python or Java, right? We cannot afford that performance hit. And so there's a lot of things that you get away with, and if you're not paying attention, they're not actually legit, right? C++ is somewhat unique in that fashion, right? And if this, at the same time, like, if we promise instead that every existing C++17 program will work forever, not only will C++17 be the last version of the spec, right, but we won't ever be able to produce newer or better compilers for C++17 because there's UB, right, just straight up, right? You can't have it both. So if you can't have it both, we just need to be clear about where these boundaries are, right? On behalf of the committee, I encourage you to keep an eye on SD-8, right? If you Google search for isocpp.org SD-8, you'll find it just fine. Otherwise, it's like 3 or 4 clicks through the website. Keep an eye on that, right? As we figure out how to refine it to be more clear, so we fix the thing Greg pointed out, right? It is there for you. It is not standardese. So it should be a clear place to negotiate what these norms look like. And that's my talk. Thank you much. Questions?
I have another question. I didn't want to state it at the time because I wanted to make sure you had time to do your talk. Going back to the point about metaprogramming against the STL, as somebody who has done that, and for what I think is a fairly legitimate reason of taking other code which has the same type of functionality as the STL and migrating it slowly to use the STL and metaprogramming against it in order to detect whether you're using an official STL collection or another data type collection and performing the same operation, so I don't have to do a massive one-time upgrade of everything, but I can do sort of a gradual upgrade of stuff. Have you considered providing some sort of type trait information or something in the library that would allow me to get the behavior that I want for detecting whether you're using an STL container or not without having to explicitly call out the methods and methodologies that currently exist in the standard library?
So I think that's the first time that I've heard a request like that. I suspect that people's hygiene in C++ being what it is, like, it would be like days before someone said my vector and added the type trait, like specialized the type trait to say that it's actually stood. But you're not wrong. Like, there is some room for that. And one of the points that it is very salient here is all of the things that I'm listing here are not UB, right? Like, if you have thought it through very carefully and you know, like, these are the rights that we reserve, right? So long as you know, like, what we are reserving and why, like, you can probably do that carefully and correctly and be okay, right?
I'm more concerned with, is there a better way to do it than what I have?
That is too complicated for the margins of a air chat. And
I have one.
Was that? Will concepts have something like that? I doubt, but I haven't thought about that. So, CJ.
Hello, boss. So I might have missed it. I apologize if I did. Was there anything about friending things instead? And if not, what are the rules around users friending things from std into their own types?
Give me an example.
So, the example I'm thinking of is when I was modifying the internals of Absel fixed array, and someone had friended fixed array so that other users could make a fixed array of this other type that they created that called a private constructor, the private default constructor. Yes, I know, I did have to fix that bug. Okay, so that was one thing. It was interesting to me because I realized someone could now expect me as the owner of fixed array to call the private constructor, or private default constructor, and they were depending on that. And I was wondering if there are any rules in this SD-8 about friending things instead.
You saw the full text of SD-8, but you also just volunteered to write a paper to extend it with one more bullet point.
All right, thank you.
So going back to ADL, you said that for your own code base, you would have a tool and you could run it and it would work.
Yeah.
But what if you could give that tool out to someone with a very different code base and who is not Google, something like Microsoft or Bloomberg, and then they could use that, and then as impartial people, they could say, okay, we got that, we did it, it works, and based on this, maybe we would get more acceptance.
I have been telling the committee that we can and should be relying on tooling to solve these old problems.
Yes, but measurements are always nice. It's like you have a code base made by completely different people, completely different style, and your tool still works, and you can prove that.
Yeah.
And that's
the concern, as far as I can tell from the committee, is not trusting the tool. The concern for the committee is literally there is code that is 25 years old that continues to work, and we prioritize that. And that is bananas to me. Yeah.
So in real life, I think you don't simply just bump a C++ version. We bump a compiler version and then bump a C++ version. So do you know anything about preserving a behavior of undefined behaviors between compiler versions? Oh.
Aspar says there's a paper. Yeah.
Okay, can you share a link in the CppCon channel at Slack? Okay,
we will share a link on Slack to that paper.
Regarding ADL, since the SD-8 is basically discouraging using free functions?
No, unqualified free functions.
Unqualified free functions, right, yes.
If you put any namespace on it,
Perfect,
it doesn't have to be the full qualification, just your most current namespace.
Right.
Fine.
So, okay, that actually answers my question.
Yeah.
Yep.
Yeah, once you have any namespace qualifier on it whatsoever, ADL is turned off. I think it is also the case that if you just wrap every function call in parentheses, that ADL is turned off, but that sounds worse. Don't do that.
Right, okay, yeah. The second part was whether it's a good solution or to fix it is to just put everything instead of a namespace into a class and then make that static functions.
We have legitimately had discussions about moving all types into a different namespace and then declaring them out so that there was a separate thing there. We probably won't do that because it will explode linker input sizes by the size of that extra namespace, and it just gets silly. And we shouldn't have to work around this.
Yeah, right.
Solving this at the wrong level. So.
Thank you.
Have you given any thought about how contracts play into this? What the evolution of a contract of something in the standard library might be?
Question is, how do contracts play around with this? And I think, for the most part, contracts are primarily the preconditions, postconditions for this at runtime, which is subtly different than the usage patterns of how does a programmer interact with this symbol.
If you can use the contract or whatever to drive optimization or whatever, then maybe it'll...
I don't see a connection between the two, but it is possible. So we have one more real quick.
The finality of standard classes. I guess I have some coworkers and I've seen paradigms that exist out there where people will extend
standard objects that don't have virtual destructors and things to the effect of this, but they'll get away with it by doing it privately or something to the effect of.
Right. I have, in many idle conversations, it has been discussed that we would be happier if everything in the standard was final. I think if we had to do it over again, they probably would be. At the same time, it doesn't really hurt anything since nothing is virtual. U deriving from vector doesn't preclude us from doing anything to vector. I have not been able to come up with any weird scenario that make it harder for me to make a change by deriving from something that wasn't intended to be derived from. It's just icky though, so I don't know. It's not super important either way. But
sure. Just figured this was the appropriate context to ask.
Yeah, it's a reasonable context for it. Anyway, we're out of time. Thank you all very much.